So we're live on YouTube. We're just gonna wait until 8 o'clock. I'll switch back to the overhead mode so you can see the lecture for you in class. So those of you watching on YouTube Live, can you hear me? Maybe if I talk more, you could tell me if you can hear me okay or not. Go ahead and type a comment if you can hear me. Okay, they can hear us. I guess I can get started on attendance. Maya Allison. Ariana Butler. David Coendo. Austin Cook. Hai Deng. Jose Favela. Brianna Garcia Alonso. How do you say that?
Garcilaso.
I'll just say Brianna or Brian? Brianna. Bo Hackworth. Isabella Holt. Marcos Lopez. Okay. So Jessica Becker. Zach Winters. So who else is online? I'll go ahead and take attendance while you're here. Okay, I have Zach Winters. So who else is watching online? Chloe. Okay. Alexander Perez. Ricky Randlees. Hey, if you're watching online, tell me if you're here. Just type in a comment if you can. So who didn't I call? What's your name?
Taylor Williams.
What is it?
Taylor Williams.
Butler?
Taylor Williams.
I'm really hard of hearing.
Sorry. His mask is going to stop.
Oh. Oh, I didn't call your name because you're in group B.
Okay.
Hackworth?
Yeah.
Bo?
Yeah.
Anybody else that didn't get? Okay. Okay, if you just joined online, go ahead and tell me if you're watching so I can take attendance. All right, for the in class, I'll switch back to the regular overhead. There we go. All right, we're going to go ahead and start. So my recommendation is when I send after I send the notes, the lecture notes, if you make copies of those and bring those to class with you. It might be easier than trying to write down everything. There will be some things for you to fill in, but it'll save you some time and effort if you make notes, if you make copies of those notes ahead of time. Okay, so we're going to go ahead and start in Chapter 2, Section 1, Part A. This section is on solving linear equations. So did everyone see the attachment of the notes that I sent in the email? Okay, so you at least have them, and you can also view the YouTube video afterwards if you need to, if there's something that you missed during class. Okay, so we're going to start out with a definition. A solution to an equation with a variable is a numerical value that produces a true statement after the variable is replaced with the numerical value. If replacing a variable in an equation with a numerical value produces a false statement, then that numerical value is not a solution to the equation. So you can try this for a couple of minutes on your own. Determine if either of the values, x equals 5/3 or x equals 7/3, is a solution to the equation 3x plus 4 equals 6x minus 1. So I'll just say something about the equation first. On the left-hand side, the variable x appears. 3x means 3 times x, and then after you multiply 3 times x, you add 4 on the left-hand side. On the right-hand side, you have 6x minus 1, which means 6 times x minus 1. So one at a time, start with x equals 5/3, replace x everywhere that it appears with 5/3. Do the arithmetic and check to see if the result is true or false. Yeah, regarding calculators, for quizzes and tests, the TI-30 is the calculator that you're restricted to use. So if you have a super powered calculator like that one, that's too powerful for this class. So a TI-30, though they don't cost very much, around $10, I think, something like that. Okay, let's check to see if 5/3 is a solution. So 3x plus 4, we write 3 times 5/3 plus 4. On the right-hand side, 6 times 5/3 minus 1. So 3 as a whole number, you can think of 3 as 3 over 1. And then when you multiply two fractions, you just multiply the numerators and then multiply the denominators. The same with 6, you can think of that as 6 over 1. So 3 over 1 times 5 over 3. In the numerator, 3 times 5 is 15, divided by 3, and then plus 4. On the right-hand side, 6 times 5 is 30 in the numerator. 1 times 3 is 3 in the denominator, and then minus 1. And then do the arithmetic. 15 divided by 3 is 5. So we have 5 plus 4 on the left-hand side. On the right-hand side, 30 divided by 3 is 10. And then we have 10 minus 1. And then a little bit more on the left-hand side, 5 plus 4 is 9. And on the right-hand side, 10 minus 1 is 9. Since the resulting equation is true, that means x equals 5/3 is a solution. So what does that tell us about the other candidate, x equals 7/3? Some equations have more than one solution, but other types of equations only have one solution. What about this equation? Does this have more than one solution, do you think? Well, you'll learn that linear equations, this is a linear equation in the variable x. A linear equation in a single variable only has one solution. But just for practice, let's test x equals 7/3 anyway. So we go through the same process, replace x. Think of 3 as 3 over 1, and so we're going to multiply that by 7/3, and then plus 4. On the right-hand side, 6 times x, think of that as 6 over 1 times 7/3, and then minus 1. And hopefully, perhaps you've seen this before. Whenever you multiply two fractions, you can look for common factors from the numerator and denominator that cancel each other out. So in this case, 3 divided by 3 is 1. So they cancel each other out. On the right-hand side, 6 divided by 3 is 2 in the numerator. So if you do that cancellation, so 3 divided by 3 is 1, so we just get 1 times 7, or 7 plus 4. And then on the right-hand side, 6 over 1 times 7 over 3. 3 goes into 3 once, and it goes into 6 twice. So what we have is 2 over 1 times 7 over 1, which is 14, and then 14 minus 1. Then we write 11 equals 13. This is false. So we were expecting that, a false statement. So x equals 7/3 is not a solution. Yeah, so someone online asked about a TI-36X Pro. I'll have to look into that. I'm not familiar with that calculator. Why don't you send me an email about it, and then I can get back to you on email. Hey, here's another example, another problem. Determine if either of the values n equals 2 or n equals 5 is a solution to the equation. Let's test n equals 2 first. So on the left-hand side, we're starting out with the equation 2/3 times the quantity 3 times n minus 6, and on the right-hand side, 5 minus n. So we'll just replace every n with 2. So we get 2/3 times the quantity in parentheses 3 times 2 minus 6. On the right-hand side, 5 minus 2. Then we do some arithmetic, work inside the parentheses first. 3 times 2 is 6, so we get 6 minus 6. On the right-hand side, we just get 3. On the left-hand side, we get 2/3 times 0, because 6 minus 6 is 0. But any number multiplied by 0 is 0, so we get 0 equals 3. And this is false. So n equals 2 is not a solution. Okay, so what does that tell us about n equals 5? Well, it doesn't tell us anything. N equals 5 doesn't necessarily have to be a solution just because n equals 2 is not. So we need to test n equals 5 also. So replace every n with 5. So on the left we have 2/3. And then in parentheses, 3 times 5 minus 6. On the right-hand side, 5 minus 5. Okay, on the left-hand side, 2/3, and then in parentheses, we'll do the arithmetic. 3 times 5 minus 6 is 15 minus 6. The right-hand side is 0. The left-hand side, 2/3 times 9. We can see that we're going to get a false statement, but let's go ahead and simplify a little bit more on the left-hand side. 2/3 times 9 is 6. I'll write a little bit of detail here. 2/3 times 9 over 1 equals 0. Whenever you're multiplying two fractions, 9 over 1 is a fraction. It's an improper fraction, but it's still a fraction. Whenever you're multiplying two fractions, you can look for common factors from the numerator and denominator that cancel each other out. So 3 goes into 3 once and into 9 3 times. So we're just left with 2 over 1 times 3 over 1, or 2 times 3. So we get 6 equals 0. This is false. So n equals 5 is not a solution also. N equals 5 is not a solution. Okay, so read this paragraph at the bottom. We'll read it. If testing to see if a numerical value is a solution to an equation produces a false statement, then one wonders what must be done in order to determine what a solution to an equation is, if a solution exists in the first place. So it is possible to write down equations that do not have solutions. But we want to know how to find a solution if there is one. And so this section 2.1, chapter 2, section 1, is the section on how to solve linear equations. Okay, so we'll move on to the next page. So here's a definition of a linear equation. A linear equation in the variable x can be written in the form a times x plus b equals 0, where a and b are real numbers and a is not equal to 0. So variables besides x can be used. When you start working in the Newton software, you'll encounter all kinds of different variables. So any letter is a candidate for a variable. We often use x. It's sort of a tradition. Okay, so here's a general strategy for solving a linear equation. This can also be found in the online textbook, the OpenStax textbook that you have free access to online. And it's chapter 2, section 1 in the OpenStax textbook. Okay, but the general strategy, step 1, simplify each side of the equation as much as possible. So this might mean that we have to apply the distributive property. The distributive property of multiplication over addition. I'll point this out when we encounter it. Apply the distributive property of multiplication over addition. If it's needed, it won't always be needed. If there are like terms that can be combined by adding and subtracting on the left-hand side, you can do that. So combine like terms by adding and or subtracting. So the primary goal is to not break any rules when you're simplifying. So endeavor to learn what the rules of algebra and arithmetic are. If you break a rule, then all bets are off. Okay, then after step 1, after you've simplified each side as much as you can, then you want to collect all the variable terms on one side of the equation. So every term that has a variable in it, you want to move them all to one side of the equation. But you have to do it legally. You can't break the rules. You have to do it using proper algebra and arithmetic. Okay, so if you have all of the variable terms on one side of the equation, then step 3 is collect all of the constant terms on the other side of the equation. So the constant terms are the numerical terms or the numbers. They are the terms without variables. Okay, step 4, make the coefficient of the variable term equal to 1. The coefficient of a variable term is just the numerical number that you're multiplying by the variable. I'll point that out in a couple of minutes. We've already encountered coefficients today. I just didn't call them that yet. Hey, the way that you make the coefficient of the variable term equal to 1 is, well, you can do it in one of two ways. If you have a coefficient that's not equal to 1, you can divide every term on both sides of the equation by the coefficient of the variable term. Divide every term on both sides of the equation. Divide every term on both sides by the coefficient of the variable term. The idea is if you divide a non-zero number by itself, you get 1. And you'll see that if it's still not clear to you. An alternative, if you would rather, you can multiply every term on both sides by the reciprocal of the coefficient of the variable term. So dividing by a number is equivalent to multiplying by the reciprocal of that number. I'll show you how that works too. But I might as well try to squeeze that in here. You can, alternatively, you could multiply both sides by the reciprocal of the coefficient. So maybe there's a lot of words that you're not familiar with, like reciprocal. It's possible that you're not sure what that means. So we'll try to clear up everything if you have questions. So multiply both sides by the reciprocal of the coefficient. Okay, then the last thing to do, check the result by substituting. So when you check, that's like what we did in the very first part of the class. We checked to see if certain numbers were solutions just by substitution. So that's what this means. Check the result by substituting. So this is a neglected step. It's something that all of us, well, I can't speak for you, but oftentimes I'm too lazy to do it. But with practice, sometimes you can tell just by looking. You don't have to write anything down. You can just investigate it by looking to determine if the result really is a solution. Okay, let's do some examples. Putting those 5 steps into practice. Okay, apply the general strategy for solving a linear equation. So on the left-hand side, we have 3 times the quantity I have a set of parentheses, so inside the parentheses I have 10 minus 2 times x. So we're going to apply the distributive property over subtraction. We could call it the distributive property of multiplication over addition, because every subtraction is equivalent to some addition. In fact, we define subtraction by addition, adding the opposite, So anyway, it's still the same property. Okay, so 3 times the quantity, 10 minus 2x plus 54 equals 0. Okay, so we're going to simplify the left-hand side. 3 times 10 is 30. And then we're going to subtract 3 times 2x, which is equivalent to subtracting 6 times x, and then plus 54 equals 0. Okay, and we always have choices. We can, if we want, we can put all of the variable terms on the left-hand side and all of the constant terms on the right-hand side. You can do it that way. You don't have to do it that way. You can put the variable terms on the right-hand side and the constant terms or the numbers on the left-hand side. And you don't always have to do it the same way, but what I typically try to do often is I do what's easiest. It looks like the easiest thing for me to do would be to add 6x to both sides so that 6x is on the right-hand side. So since we have, on the left-hand side, we have a minus 6x, I want to add 6x to both sides. So on the left-hand side, we'll be left with 30 plus 54 equals 6 times x. And now we have everything that we want. I mean, there's more work to do, but we have the numerical constants on one side of the equation, and we have the variable part on the other side. And then we simplify the left-hand side. You know, I sort of broke the process. I'll point that out here in a second. We're okay though. 30 plus 54 is 84 equals 6x. And then the last thing to do before we check is we can divide both sides of the equation by the coefficient of x. 6 is the coefficient of x because that's what we're multiplying by x. We call 6 the coefficient because it's the numerical factor that we're multiplying by x. So if we divide both sides by 6, we get how much? We get 14, right? So divide both sides by 6. So 14 equals x. Is that what you get? Okay, the alternative here, in this case, it seems easier just to divide both sides by the coefficient of x. But the other option is to multiply both sides by the reciprocal of 6. Think of 6 as 6 over 1, and the reciprocal is 1 over 6. So you could, it looks like it makes it more complicated. You could multiply both sides by 1/6. You still get the same result. So 1/6 times 84 is also 84 over 6. And then 1/6 times 6 is 1, and 1 times x is x. Okay, what I was alluding to earlier was on the left-hand side, we can simplify further before moving the variable part to the other side. We can add 30 and 54 first. And then we can proceed to add 6x to both sides. You don't have to do it that way, as long as you don't break any rules in the process. There are often more than one way to get to the solution. Okay, let's move on to the next example. So number 2, this time we have -2 times the quantity 11 minus 7y, and then minus 60 equals 2. So first we will apply the distributive property of multiplication over subtraction. We multiply -2 times 11 to get -22. And the next multiplication, we are in effect multiplying a negative times a negative. A negative times a negative is a positive. So -2 times -7y is positive 14y. Okay, we can simplify further on the left-hand side. We have -22 minus 60. So we can write this as -82 plus 14y equals positive 2. And to get the variable part by itself, on the left-hand side, we can add 82 to both sides. So we're going to add 82 to both sides, and we get 14y equals 84. And then divide both sides by the coefficient of y. So 14y divided by 14 equals 84 divided by 14. 14 divided by 14 is 1, so we get 1y or y, and 84 divided by 14 is 6. Okay, is this making sense to you? Okay, that's a good sign. Okay, more practice. So on this one, this time we have a fraction 1/4 that we are multiplying by the quantity 20m plus 12, and that's equal to m plus 7 on the right-hand side. So if you're pretty good with fraction arithmetic, you don't have to write down every single detail. But I'll write down a little bit of detail. If we multiply 1/4 times 20m, we can write it as 20m over 4. And then when we multiply 1/4 times 12, we can write that as 12 over 4. And the right-hand side stays the way it is momentarily, m plus 7. And then 20m divided by 4 is 5m, because 20 divided by 4 is 5. 12 divided by 4 is 3. So now we have 5m plus 3 equals m plus 7. Okay, so we want all of the variable terms on one side of the equation. So why don't we subtract m from both sides? 5m minus m is 4m. So we get 4m plus 3 equals 7. And then we can subtract 3 from both sides. So we get 4m equals 4. And then the last step, divide every term on both sides by 4. So we get m equals 1 for the solution. Oh, I guess we better check every now and then. So we'll check m equals 1. So we have 1/4 times 20 times 1 plus 12. We want to know if that's equal to 1 plus 7. So here we want to simplify what's on the inside of the parentheses. 20 times 1 plus 12 is 32. And on the right-hand side, 1 plus 7 is 8. And 1/4 times 32 is 8. So 88 equals 8, that's true. So we verified that m equals 1 is the solution. Okay, 3 more examples. So these are all linear equations in one variable. Okay, so on the left-hand side, we apply the distributive property of multiplication over subtraction again. So 3 times the quantity 4n minus 1 becomes 12n minus 3, and then minus 2. On the right-hand side, 8n plus 3. We can simplify more on the left-hand side. Minus 3 minus 2 is minus 5 altogether. So we have 12n minus 5 equals 8n plus 3. And I'm going to add 5 to both sides in the next step. So we get 12n equals 8n plus 8, because when we add 5 to 3, we get 8. And then let's subtract 8n from both sides. 12n minus 8n is 4n. So we get 4n equals 8. And then finally, divide both sides by 4. So this is, as I mentioned earlier, this is more detailed than is absolutely necessary, but if you need to put the detail in, then go ahead and do so. So 4n divided by 4 is 1n, or n, and 8 divided by 4 is 2. So we get n equals 2 for the solution. Okay, next one. Yeah, just a side note. I have seen in the past, on a few occasions, students incorporating the number of the problem into the problem. So just something to watch out for. So this is problem 5. And the problem is 5 plus 6 times the quantity 3u minus 5 equals negative 3 plus 2 times the quantity 8u minus 1. Okay, so we have the distributive property to apply on both sides. So on the left-hand side, we have 5 plus 6 times 3u is 18u. And then minus 6 times 5 is minus 30. On the right-hand side, negative 3 plus, and then 2 times 8u is 16u. And then minus 2 times 1 is minus 2. Okay, we can simplify further on each side. On the left-hand side, we can combine the numerical values. 5 minus 30 is negative 25. So here we'll write 18u minus 25. On the right-hand side, negative 3 plus 16u minus 2. The negative 3 minus 2 is minus 5. And so in the next step, I'm going to subtract 16u from both sides. So when I subtract 16u from both sides, I'm left with 2u on the left-hand side. So 2u minus 25 equals -5, and then add 25 to both sides. I get 2u. I'll write this in a little more detail. -5 plus 25 is +20. And then divide both sides by 2, we get u equals 10 for the solution. Okay, one more problem. Okay, here we have -12 plus 8 times the quantity v minus 5. So we have to apply the distributive property again on the left-hand side. On the right-hand side, we have -4 plus 3 times the quantity 5v minus 2. So remember to multiply before you add or subtract. It's possible to do something incorrect. I could have pointed it out on the previous example. On the previous example, where we had 5 plus 6 times the quantity 3u minus 5, we had to do the multiplication first, and then afterwards we were able to deal with the 5. So what I'm alluding to is make sure that you do not, in a case like this, add 5 and 6 first. That will give you an incorrect result. See what I mean? That's just something to watch out for. So down here, we do the multiplication before we worry about addition. So we have -12 plus, and then 8 times v is plus 8v, and then minus 8 times 5 is minus 40. On the right-hand side, -4, and then plus 3 times 5v is plus 15v, and then minus 3 times 2 is minus 6. We can simplify more on the left-hand side. The -12 minus 40 is -52, so we're going to write 8v minus 52. On the right-hand side, -4 plus 15v minus 6. -4 minus 6 is -10, so we can write -10 plus 15v. Equivalently, I could have written the right-hand side, 15v minus 10. Those are equivalent. Okay, so what should we do next? Let's add 10 to both sides. So we get 8v, and then minus 52 plus 10 is minus 42. And the right-hand side is 15v. Then subtract 8v from both sides, so we get -42 equals 7v. And then lastly, divide both sides by 7. So -42 divided by 7 equals 7v divided by 7. -42 divided by 7 is -6. 7 times v divided by 7 is v. So v equals -6 is what I get for the solution. Okay, we got through the lecture notes. So I know that some people came in. Is Ariana Butler here? Okay. Hi, Dai Deng. Jose Favela. Marcos Lopez. Okay, so some of the people online, I didn't get everyone's attendance. Is Holly there? Jacob? Okay, I got Michaela. Ernesto Vega. Okay, so I mentioned before that I have to go to another building for a 9 o'clock class. And so we're done for today. If you have some important questions that you need to ask me, send me an email. That's probably the best way to communicate with me anyway, is through email. Hey, so that's all for today. I'll send more lecture notes for tomorrow's class later today, along with the YouTube link.